Well, hello everyone. Welcome to the last lecture of the P block elements. And in this lecture, we will be covering the most nonchalant elements of the periodic table, which are the group 18 elements, also known as the noble gases. And as I already said, this is the last lecture of this series, so please let me know in the comments what you think I should do next. I am in between of these two topics like D block or you want salt analysis. Like I personally want to do salt analysis, but if you want D block, just let me know. So without further ado, let's begin. So what are the group 18 elements? The group 18 elements are, now keep in mind that we are studying P block, sure, but in the group 18 elements, we also considered helium a group 18 element despite it not having a p subshell. Okay, now so the group 18 elements are helium, neon, argon, krypton, radon. No, not radon. I mean, yes, radon is there, but before that, there's xenon. Xenon followed by radon, and then we have organoson. Now, keep in mind that the NCERT was written before organoson was discovered. Like this guy was discovered in around 2019, I guess. So, this is just an extra information for you. You don't need to remember organoson. So, resultantly, our group 18 elements are helium, neon, argon, krypton, xenon, and radon. So, why are they called the noble gases, you may ask? They are called noble because, first of all, they are unreactive. And contrary to what some people think, they actually form very few compounds. It is not no compounds, it is very few compounds because xenon and even krypton and radon are found to have made successful compounds which have been stabilized and isolated in the past. So they are not exactly completely inert, but they are quite unreactive, which means that even for making these compounds, you have to create apocalyptic reactive reaction conditions. So, which is why they are termed as mostly inert. Like most elements will not be able to land a scratch on this, and only elements like fluorine or oxygen can cause enough electron pulling to form actual bonds with these elements. So, first point, these are more or less unreactive and they form very few compounds and they are called noble gases for this exact reason. Now, let's talk about their occurrence. They all occur naturally, all are naturally occurring except for radon. Now, I don't know why our nature does not like radon, but turns out that these gases are existing, and helium, neon, argon, krypton, xenon, they do exist. But radon should be prepared artificially. I don't even know if that's possible, but the NCERT says it does not occur naturally. So keep that in your mind. And I think, give me a second. Yeah, so basically, there aren't exactly a lot of ores for this, but helium and very rarely neon, they are found in minerals which are of radioactive origin. Radioactive origin. And the NCERT mentions examples of these like pitch, blende, monazite, cleverlite. Let me just write it down for you once. I don't think you have to remember this, but these three words won't hurt your memory. It's just pitch blend, it's monazite, and it's cleveite. So remember this, or don't remember this. I don't think they'll ask, but yeah. Now, once again, let's move to the most important part of any P block lecture, which is the trends of the group 18 elements. What trends can we expect from the group 18 elements? So let's take a look into that. So first of all, the electron configuration. The electron configuration of all the noble gases is Ns2, Np6, except for helium, which has 1s2. Like helium lacks p orbitals, but since it has a complete shell, it is just as inert as the other gases in this group. So, which is why we include it in group 18. And yeah, so that was it about the electronic configuration. Now, if we talk about the ionization enthalpy, now obviously they exhibit very high ionization enthalpies. I don't think I need to explain this, but if you do want an explanation, I'll give you one. Basically, they have high ionization enthalpy because they are extremely stable. Like, you should know for a fact that a noble gas is one of the most stable elements in the entire periodic table. Like, this thing is very, very, very stable. And in order to take out one of these electrons, you have to provide an abysmal amount of energy. And that amount of energy, like, what is the purpose? So basically, they have very high ionization enthalpy, but it still does follow a trend that it decreases top to bottom. For example, say helium has, if we talk in kJ per mole, it is 2372. Neon has 2080. Argon has 1520. You of course don't have to remember these values, but I'm just telling you so you get an idea. So ionization enthalpy even in the group 18 elements does decrease top to bottom, even though they are all very high values in general for the rest of the periodic table compared to the rest of the periodic table. Now let's talk about atomic radii. The atomic radii for noble gases increases top to bottom. This shouldn't exactly be a surprise for you because the number of shells increases. This is nucleus, and the number of shells in every respective principal quantum number increases. So when this increases, the size of the net atom increases as well, and hence the atomic radii increasing from top to bottom isn't exactly a big deal. It's quite easy to remember this. And lastly, if we talk about the electron gain enthalpy, the well, it is basically the same thing as the ionization energy. If we have this nucleus and there are like electrons around it, and this, as you know, this is the structure of helium. This is very stable. So if you try to add another electron in this family, it will be like trying to become a third wheeler in a couple, which is very stable, and I don't think the atom would appreciate that, and hence they have very large positive values of electron gain enthalpy. In fact, if we talk about electron gain enthalpy in general, nitrogen, magnesium, beryllium, and all the group 18 elements are the only elements in the entire periodic table to have a positive electron gain enthalpy, which means they will not appreciate the addition of an electron. And if you want to add an electron to the nuclei, you will have to supply energy instead of absorbing it. So that was it. And the NCERT does not mention a trend in the paragraph, but if we look at the table, neon has the highest electron gain enthalpy, in group 18, and helium has the lowest. But yeah, just remember that neon has the highest. Although I doubt that they will ask this because this isn't mentioned as an explicit point. But yeah, that was it about the trends. Let's talk about the physical properties. Physical properties. What physical properties can we expect from the group 18 elements? First of all of them exist as monoatomic gases. What does monoatomic mean? Like for the rest of the periodic table, gases like H2 exist, and O2, N2, F2, Cl2. Like they need another one of their members to get stable. But these gases, they are just there. Like they exist as a single monoatomic entity. Helium exists like this, neon exists like this. That just one molecule in itself is quite stable. So this is why they don't really feel the need to make another bond with any other atom. So they are monoatomic and exist in that state only, and they are colorless, odorless, and tasteless. What is the COT? Basically, COT is a system I made to describe any gas, and it literally just stands for color, odor, and taste. Specifically, color and odor is more common. And using this, maybe you can make a table of gases with color or taste, like one gas, second gas, third gas, fourth gas in salt analysis. And this is how I will remember salt analysis. So this can help you if you want to use the system. And these gases are sparingly soluble, which means they are somewhat soluble. Like they are not extremely soluble, but they are not insoluble as well. So it is like somewhere in the between. So they are somewhat soluble in water. They have very low melting points and boiling points. And I guess this tells you why we call them the noble gases. Their boiling point is very low, so they exist as gases even at cold temperatures. And this is because they have very little to no interatomic packaging. Like their molecules are arranged together, sure, but they have very weak forces between them, like very weak. So there isn't exactly quite a strong packing here. So it's easy to give energy and just break these bonds and ascend them from solid to liquid or liquid to gaseous state, which is why they have low melting points and boiling points. And an interesting point here is that helium has the lowest boiling point of any known substance. Like this dude has a boiling point of 4.2 Kelvin. Now, just for the Celsius scale users, the 4.2 Kelvin is like it's like negative 270 degrees Celsius approximately. It's not an exact figure, but do you understand the scale of negative 270 degrees Celsius? Even in the outer planets of our solar system, like Neptune, Uranus, Saturn, Jupiter, even there the average temperatures don't go this cold. Like they might, but in many cases they don't. So helium is the lowest boiling, and that would mean to convert helium gaseous to helium liquid, you would have to go to temperature of 4.2 Kelvin. Don't even talk about helium solid. I don't know. Is it even possible? But yeah, enough yapping about helium. And helium has a property that helium can diffuse. Like basically, it can pass through rubber, glass, or plastic. Basically, helium can just phase through these substances, and it's free to be itself. Now that was it about the physical properties. Let's now talk about the chemical properties. And very evidently, chemical properties are very small in number. Now I have already explained to you why they have low chemical reactivity, but let's just read the textbook definition of that. They have low reactivity because of complete shell. Because if they have complete shell, they obviously don't have a tendency to lose that symmetry, that stability. So they do not want to react. at all. And another reason is that, I mean, a direct consequence of the first reason is that they have high ionization enthalpy and positive electron gain enthalpy. So, in order to form a bond, you either lose an electron or you gain an electron. Both of these are energetically unfavorable for the group 18 elements, and hence they have low chemical reactivity. But some of their compounds have been prepared. Compounds exist, very few in number, but they exist. So the entire procedure is mentioned here in the NCERT. But one point I want you to know in detail is that the ionization enthalpy, the first ionization enthalpy of xenon, is almost the exact same as that of oxygen. And this is 1170 kilojoule per mole, and this is 1175 kilojoule per mole. And this is how the first compound of xenon was actually discovered. What happened was some dude made a compound called O2-PTF6, and what he did was he made efforts to prepare the same type of compound with xenon. So O2-PTF6, so he wanted to make Xc2-PTF6, and he actually succeeded in making XZPTF6. And after this discovery, a number of xenon compounds he was able to make. And even in chemical bonding, we also study that compounds like XEF3, XeF2, XeO2F2, they exist. And you are even asked to draw their structures. So just remember that xenon has 8 electrons in its valence shell, and that is the most unique property of xenon out there. And that was it about xenon. Krypton compounds exist as well. But if we talk about the laboratory, we have only studied KrF2. And in fact, even radon compounds exist. For example, we know that RnF2 exists, but it is not stable enough for us to isolate it and study it. And the last point, the only elements which are not traitors in the group 18 elements, no compound of argon, neon, or helium is known. Now, I want you to notice something interesting here, that anytime there is an exception to the low chemical reactivity of the group 18 elements, it is always oxygen or fluorine causing that exception. Now, why is that? Because oxygen and fluorine have a really strong tendency to pull electrons. So what happens is that they see this guy has a lot of electrons, so they can make attempts to pull these electrons towards themselves, and sometimes this is just the energy they are putting in to remove those electrons from the shell of the group 18 elements, it exceeds their ionization enthalpy, and sometimes that bond is just formed. So this is why the compounds of xenon, krypton, and radon may exist. And that is it. That was everything for group 18 elements, and in fact the entire P block in general. So this has been a great journey, and really thank you so much for watching this series if you have, and I'll provide this PDF in the pinned comment. And basically we have covered everything in P block. So thank you.